Hello everyone and welcome back to the Intro to C course MCS 1142. Today is week 6B, June 22nd, semester summer of 2021. Today, and according to the syllabus, we will go over chapter 6, which is arrays. And we're gonna go over homework 5 and project 3 that are gonna be assigned today. So first things first, what is an array? What is an array? So an array is a series of memory locations or boxes or slots. You can call them whatever you want, where each of which holds a single item of data. So it's a container of data, container of items, container of elements. However, and of course, each item is in a box or a slot. However, the thing is, all data in the array must be of the same data type. You can't have a container of different type. For example, you either have an array of integers or an array of characters or an array of double. You can't have one array that has a integer and a double and a character. So an array, all data in the array must be of the same data type, and they are continuous in memory. And I'm gonna explain that today in memory. So this is the definition. If you want me to draw something for you, so you're gonna have the memory, right? We have a big memory. So more goes here, more goes here. We are taking this portion of the memory, and then you have slots. So boom, 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 boxes. Now, if my array is called my array, and it has a size 10, that means this my array is at index 0. Arrays starts from 0 instead of 1. So 10 items means from 0 to 9. Item at 0 can be 1. Let's say this is an integer array. Then my array 1, which is this slot, can have -5. Let's say this has 15, 3, -7, 18. So integers. This is 0, this is index 0, this is index 1, this is 2, 3, 4. So my array at 5 would be this one. So this is the value at the first slot. If I call this in my code, I'm gonna get the value 1. Now, notice how all of them share the same name, which is the array name. And we're gonna see it more in the code. Now, my array as is, so my array as is without this operator, the square bracket operator, this would be the memory address of the first slot. So it's gonna basically tell you, hey, this array starts here in memory at this address. It starts here, and since it is an integer array, that means each slot is 4 bytes. Why? Because an integer is 4 bytes. So my array is this address, then the next slot is this address plus 4 bytes. Then the next slot is this address plus 8 bytes. So you're gonna be jumping 8 bits at a time. So let's say this is at address 15, then this item, the second item, is at address 19, and this item is at address 23. This item is at 27, and so on and so forth. You're jumping 4 bytes because this array is of an integers. If this array was of characters, then you're gonna be jumping 1 byte because each character is 1 byte. So this address would be 15, the next one is 16, 80, 16, 17, 18, 19, etc. This is a basic idea for now. So what's an array? This is an array. It's a collection of items or container of items where all items must be of the same data type and all items are continuous in memory. Continuous in memory means the first item is right behind the second item, and the third item is right after the second item, etc. They are continuous in memory, 15, 16, 17, etc. This is the basic idea. Now let me do some code. Let me do some code, and I'll type it first, and then I'm gonna explain it. So here I type my code. Here I'm declaring an array of the type integer that has 6 items. Well, as a matter of fact, I want 5 items. So I want an array with 5 items. Then I'm iterating 5 times, and on each iteration, I'm telling my code that this array at this index, whatever the value is at the current iteration, I want to set the value to be 0. Then I'm displaying my array. So if I want to step in my code, here it generated my array, it declared my array. Notice that it has junk values. This would be the address of my array, the beginning address. So my array has this value, which is the address of the first item. And this is in hexadecimal. And I'm going to explain hexadecimal if we have more time. Hexadecimal is different than a decimal or an integer. It's base 16 instead of base 10. Then I have 5 junk values. So I'm entering my loop. At this iteration, I is 0. That means I'm telling my program, my array at index 0, I want to set the value to 0. And then I'm hitting F10. If I hover my mouse now, you're going to see that the first item has the value 0. If I do this, right now I is 2, right now I is 3, right now I is 4, right now I is 5. Well, no 5, because 0 to 4. Then if I hover my mouse, it's going to be 0, 0, 0, 0. So I populated my array based on a loop. Then I'm going to display in the same fashion. I'm telling my program, at this iteration, what is I? I is 0. Okay, display my array at index 0. It will display on the screen the first item, 0. Then the second item, which is I1, then I2, then I3, then I4. If I look, I'm going to see the values. I can, as a matter of fact, give it an actual values of I. So for example, I'm going to say I, and then I'm going to display it. So if I run again, it's going to display 0, 1, 2, 3, 4. Why? Because these were the values of I at the time of the settlement, not settlement, setting the value. At I0, I set the first item. Then at I1, I set the second item. At I2, I set the third item. So 0, 1, 2, 3. When I was 4, it was the last iteration. And when it became 5, it broke out of the loop. Okay, so this is how you populate an array using a loop and displaying it in the same fashion as well. Then I'm going to show you how you can initialize an array. So how to declare an array and then initialize it with a value. Remember that you can declare my int, and as well you can declare my int 2, for example, and initialize it with a value, give it a value. So in this example, it's 10. So this is uninitialized variable. This is an uninitialized. This is an initialized variable. We can do the same with arrays, but there is a special syntax. So my array 2, which is of the size 5, will be equal, and I open curly braces. I open curly braces and they are separated by a comma. In this example, 1, 2, 3, 4, 5. These are the values of my array. Now, if I give it one more comma, it's going to be an error. It's not going to accept it. It's going to say, hey, something is wrong. This, strange. So it took the comma, but it didn't take the variable, the value. And if I give it 4 as well, it's gonna declare the first 4, and then the rest are gonna. Oh, this is an old one. Oh, I'm displaying my array. So notice the difference. If you don't initialize an array, the default values are gonna be junk. So here it's uninitialized and I'm displaying it. Notice it's junk values, trash. However, if I initialize part of the array, in this case, the first 3 items only, then the rest are not gonna be default, are not gonna be trash. They're gonna be zeros. So you need to understand this. So by just initializing the first item of the array, the rest of the items are going to be zeroed out, okay? They aren't going to be trash. And it's a habit to do. And like when you start using arrays, you're going to be doing it because you don't want to see trash values. Then you need to know that an array always has a fixed size. So for example, if my int2 is going to be read from the user, for example, asking the user, hey, how much items do you want? What's the size of your array? And then the user enters a variable from the screen onto the variable, and then I use that variable inside my array as a size. It's not going to accept it. Why? Because arrays need to be fixed size at compilation time and not at runtime. You cannot have a variable size for the array. The array at the compilation part, at the compilation phase, means before I hit this button, when it compiles the code, this value needs to be fixed, needs to be constant, cannot change. You can't say, hey, this execution, I want 5 items. Next execution, I want 10 items. That's not how arrays work. There are different solutions, but it's not for this course. But the good habit to do is using what's called a symbolic, what was the symbolic constant. Symbolic constant are basically telling the system that you have that you declared or defined a value, and it goes like this. So define, and I'm gonna tell you why you would want to use that. You're gonna say define size space 5, no semicolon, nothing. So this now at compilation time, the compiler will go anywhere that we used the word size, and it will replace it by 5. Why do you want to use that? Because if you have my array 1, and then my array 2, and then my array 3, for example, students initial, first initial, yeah, it's a character. It's char. Students initial. Then you have an array students grade. Then you have an array for double. Well, let's say this is student age, for example. So it is an int. And then you have a double. So student grades would be double. So age. And then double student grades, right? Initials, ages. So, and imagine these are in different places in the code. So at this point, I do student initials and I do some code, and then I declare another one called student ages, and then I do some code. Then I declare another one called student grades, and I do some code. And then Each semester, I need to change the size. And by using the symbolic constant, I go in one place, only in one place, and I change the size. This semester, I have 20 students, and then I compile. Next, what was the error? Okay, this is the error, so we don't need it for now. Next semester, I have 25 students. So I go to one place and say 25. Why? Why this is better? Because if I didn't have this, if this was not there, then this would be 20, this would be 20, this would be 20, correct? And then I started a new semester and I need to go to the code and change all the 20s to be 25. I'm gonna go to the code and start looking at my code, which line, okay, this line, this will be 25. Then I go through my code, oh, okay, this 5, this 20. Then I go over my code and I miss one, I don't see it. You know, I'm hungry, it's lunchtime, or I arrived late, I'm sleepy. For any reason, I missed this line. I continue with the code and I tell my boss, hey, I'm done. We are ready for the release. However, I forgot to change one, and this will cause a lot of troubles. 5 items will be skipped. Instead of 25, I have 20. So this is why it's a good habit to always define one variable called symbolic constant, and then you put the symbol in everywhere you need. This way, every semester I go to one place and I change that variable. So that's called symbolic constant. If you don't like symbolic constants, you can declare a const int, call it my size, and give it a 5. The fact that it is const, now I can use it in my arrays. Const int my size. If this word is not there, then it's not going to accept it. It's going to say, hey, you can't have a variable. It has to be constant. So const. Cool? Cool. Then we're going to go over an example to, for example, adding up all the values. Let's say you have an array of 10 items. Each item, each slot, each position, or each location has a value. And we want to calculate the total of the array, the sum of all the items. So let me remove all these. My array here, I'm going to display, but I don't need to display now. I'm going to go ahead and define, because it's a good habit. My size is 10. Then I'm going to say int my array of my size. And it's going to be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I initialized it. I gave it values. Then I'm going to say I would like a total, and my total starts from 0. At the very beginning of my program, if I don't go over my array, the total would be 0, correct? Correct. Then I'm going to put a loop. I'm going to say int I equals, starting from 0, as long as I is less than size, whatever the size is, right? Whatever the size, whatever the value of this at the compilation time, I would like to iterate it. And then I'm gonna increment. Now on each iteration, what I'm gonna do is I'm gonna say total is equal whatever total is plus my array at this I, whatever the index is. At the very end, I'm gonna print f total. Total is now I can replace this with plus equal. These are the same. Total plus equal my array means whatever total is, add this value to it. Now, what is 1 plus 2 plus plus plus? We're gonna go over it. Let's see. What did we have? We have here 55. So if I say 1 plus 2 plus 3 plus 4 plus 5, 6, 7, 8, is 55. So I calculated the total of all my items. Let's say your array is the sales and you have 12 months. The size is 12. This month you did $100. Next month you did 250. Then you did 3,000 and you started going viral. Then 4,000. Then you started doing 25. Let's say 6, 5, and then you got really lucky. Then back to after holidays. So you started going down. Then 8. Then you got broke. Something happened. Then 10. So what's the sum of this? 39,869. Cool. So this is how you sum all the elements of an array. Another example would be is to roll the dice. For example, let's roll the dice 100,000 times and see the probability, the result. How many times we got phase 1? How many times we got phase 2? How many times we got phase 3, etc. So in my in this case, I'm gonna have so an array of 1 to 6 or an array of 0 to 5. Let's have it as size equals 7, just so I don't confuse you, because I don't want I plus 1 to confuse you. So let's stick with I. Then I'm going to remove all these. Then I'm going to say I would like an int of let's call it a frequency, right? The frequency of each phase of size this, and I want to initialize the first item as 0. That means all items are 0. Then I'm gonna call srand, because I want to generate random numbers, right? Time. Then I'm gonna say seed my generator. Then I'm gonna say for int I equals 0, I less than whatever my size is. Actually, not my size, no. I wanna do it 60,000 times, right? So from 0 to 60,000 means 60,000 times I plus plus. On each iteration, I'm gonna generate a random number and then I'm gonna populate. If I get, so what are the values? Since it's 7, that means I have 0 at 0, 0 at 1, 0 at 2, 0 at 3. Let's do it here actually. Why I don't need to comment. So 0, 0, 3, 4, 5, 6, 7. That means at this index, I have this index, this index, this, right? I have 0 at this index, 0 at 1, 0 at 2, 0 at 3, 0 at 4, etc. Now I'm going to do it 60 times, 60,000 times. On each time, I'm going to generate a random number between 0 and 6. But since the rolling dice has only 6 sides, so I'm going to generate a random number from 1 to 6. I'm going to skip the 0. If the random number I receive is 1, I'm going to increment this value. So now this value becomes 1. Now this value becomes 1. On the next iteration, if I also receive 1, then I'm going to increment this to 2. On the following iteration, if I get 3, now I'm going to increment this. So 60,000 times, and then we're going to watch how many times did I get the number 1, how many times did I get the number 3, etc. So let's go ahead and do it, 0 it out. And then here I'm going to say int current phase equal random Modulo 6 means 0 to 5. Add 1 to it means 0 to 6. Then I'm going to say whatever, so L frequency, whatever the index of that plus equal or plus plus, just increment it. Boom, 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 boom. If that's confusing, now you have this code, run it and display frequency. So let's do it just so you pause the screen if you need to. I less than, in this case, my size, and then I plus plus. In this case, you're gonna print f. You're gonna say consume 4 characters for this number, and then consume, for example, 17 numbers for 17 characters for the following number, and then you're gonna display I, right, at 0, 1, 2, 3. At 0, you're gonna have L frequency of I, yeah. So at 0, you have this value. At 1, you have this value. At 2, you have this value. Now you can do that. You go ahead and you can do that and display it. But I'm going to make it from 0 to 5. So 6, if you think this is confusing, so I'm going to do it the other way. Means from 0 to 5, then this will be 0 to 5, and then if it's 0, increment that. If it's 1, increment that, etc. Then I'm going to select, yep, so this is correct. Then here, I'm going to say +1. That means if the index is 0, I want to display 1 instead. Why? Because we don't have a face 0. So I'm mapping 0 to 5, right? We have 0 to 5, 6 faces. So I'm mapping 0 to 5 to be 1 to 6. So here is the results. Phase 1, we received 100,000, 147. Phase 2, we received 100,000. So almost equal, you notice? Almost equal. So this random number generator is equally random. It's equally random. That's pretty cool. Boom, 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 boom. For 60,000 times, let's add 600,000 times. Wow, pretty cool. Let's do 6 million. Wow. Pretty cool, indeed. So that's how you roll a dice 6 times, and you check how many times you get each of the faces. The next topic I want to speak about is, we are done. We talked enough about integers. I want to speak about character strings, which is called C string. Let me drink some water. I'm looking at the book just to see that we went over all the topics of the integer before I move on to strings. Okay, so page 226 is where the strings starts. Let's see where to start. So first, what is a C string? C string is an array of characters in the C language. If you have a C string of the size 7, then you can only put 6 characters. Why? Because the last character is always reserved for the null character. For example, here I have size 5. So I'm going to say char, my string of that size is equal to character H, character E, character L, character L, character O. How many are these? 1, 2, 3, 4, 5. Now, if I execute, so I have 5 characters. The size is 6, but I have 5 characters. And this is the right way. Why? Because if I hover my mouse, you're gonna see that HELLO is the entire character, and I didn't see junk, right? Remember that whenever you initialize, whenever you uninitialize, the default value is trash, or if you partially initialize, there should be 0 somewhere, but there is no 0. Why? Because the last character is always reserved for a null. You see the null character, this \0 is the null character. This character is the delimiter. This is the sentinel where the program knows where the string ends. In other words, if you have my string of size 100, and then I add here \0, which is the null character. Now, my string is not gonna be 100. Why? Because it's terminated at the 6. That means it's hello. It's no longer 100. This identifies where the string ends. So now if I say printf a string, and then I give it my string, the printf will know when to stop. It will know where to stop. Why? Because I have the terminator. If I don't have the terminator, then printf will not know where to stop, and it will display all the rest until the 100. Actually, there's it might not know at all. Yeah. Well, let's hover my mouse on it. Stop. Oh, because they are all nulled. Because it happens sometimes that your memory at this point, which is 000A00, this block of memory is all nulled, you know, but it's not guaranteed. It's not safe to just assume that the entire block of memory or the entire section of the memory is all by default null. There is null character in it. It's not guaranteed. This is pure luck, pure chance that the entire block of memory is already null. That was just pure chance. Let's try again. Let me remove this. Try again. Again. Let's add 1, 2, 3, 4, 5. Yeah, we will never know. And it exited. Well, we will never know. Anyway, what you need, what you are responsible of is you need to terminate your strings. And this is how you initialize a character. An array in general, whether it's a character or not. However, you can also give it literal. You can also give it literal like this. Now it's the same. This will become terminated by null. It will automatically add null to it. So it was 6. Now if I go again and I hover my mouse, it has the null. So when you give it literal, you don't have to give it the null. And also you can read from the user. So I'm gonna say no value, right? No value, but it is of this size, and I'm gonna say it is size 20, just so we can like type a name or something. Then I'm gonna say enter a string no longer than how much? No longer than 20? No, no longer than 19, because I can't put a 20 in a size 20. I need to reserve 1 for the null. So enter a string no longer than 19, and then I'm gonna scan f. In this case, I'm gonna scan 19 into string, and where I'm gonna put them I'm gonna put them in my string. Notice in the scanf, I don't have the ampersand character. Why I don't have the ampersand character? Because if I have an integer and I say ampersand integer, that means I'm telling scanf, hey scanf, I need to read from the screen and put it in that address, in that memory address. So I give it the variable integer, and then ampersand becomes the address of this integer variable. But with arrays, remember how we said the name is the address? So the name itself is the address. I don't have to put an ampersand to tell scanf, hey, the address of this array. No, the name, oh, the name of this array. The name of this array is by itself the address. Return value, ignore scanf. Yeah, ignore it. I don't want anything from scanf except to read into this. Then I'm gonna say, let's print what we received actually. The string is whatever this string, and it will know when to terminate. Yeah, basically my string. Let's run. So enter less than 19. 1, 2. So the string is Khalil. Oh, you know why? Because I didn't give it. I put a space. That's why. So I'm telling it maximum 19, but it didn't read the space. So how can we do that? Well, it's not gonna know with the C language. It has to be. It has to be the entire. It has to be the entire word on one line, unless I do it in 2 strings, and then I say like, consume at minimum or at maximum 19 space, at maximum whatever the last name. So that's why in all, like, you have to say enter your first name, and then the user enters first name, then enter last name, then the user, because if you put it in one go, you're gonna lose anything after the space. Yeah, this is something we need to live with the C language. With saying that, the next topic is passing arrays to the methods. So remember how we used to write functions and then give them values, integers. You pass the integer to the function, or you receive back from the function. So now we're going to learn how to pass an array to the function. So I'm going to leave those. I'm going to leave this. And then I'm going to let a method display. So display. And whenever you pass an array, you pass the name, basically the address. So you're telling the worker, hey, there is an array that starts at this address and its size is this. So the display will receive what? Will receive a char array and then a size. So that size is an int, a size. Means it will know, hey, you received 15 and there are n items after 15. And this is a character. That means whatever n you receive, it jump 1 byte at a time. So now I'm gonna say display my array. No, display, yeah, my array. Or if I wanna iterate and display 1 character at a time. So for int I equals 0, I less than a size, and then I plus plus. In this case, I'm gonna print a character. So print character space, my array at this I. So now go, hello. Oh, it's waiting for 16 characters. Yeah. Hello is how much? 5. Hello. Where is it being stuck? 5. Oh, space. That's why. So it has a hello. I'm gonna step into. So notice I received the address. Now Visual Studio is showing this. Visual Studio is showing all the values until a null character, but I received an address and then I received the size. In this case, it's 20. So I'm gonna display at this, at this, at this, at this, etc. What is displaying so far? So it's displaying hello nulls, or mostly not nulls actually. It's not gonna show me. So you see inside this function, locally to this function, if I open, I only see the first item because this, what we received is an address. Now, yes, if I hover, it's gonna, this is a different display. So yeah, it is how it is. Yeah, so this is how you pass an array to the function. Now, how to return an array from the function is the same. You're gonna say char pointer, as a matter of fact, so asterisk. Now, whoever calls this function will give it a size, right? Will give us the address of the first item plus a size. You can do whatever you want in the values. You can change the values. If it's hello, you can change hello, put your name, and then you can return. When you return my array, for example, like this, return my array, you are returning the address of the first item to the caller. So whoever called function will receive back the address of the first item, that basically the same. If it's gonna be different if you copy paste arrays. If you declare a new array here, for example, char my second array, right? And it is of this size, etc. My size. So if you return my second array, it's going to be new address. So new address of the first item, and the caller will know the size because they passed us the size. So the boss function gave us the size. Then it's going to receive an address to the first item. We're going to tell the boss, hey, here is the new array, and it starts at this address. The boss will know that that new array has the same size and it starts from whatever size I sent it to. The boss sent us the size, we return a new array, so it works. So this is passing an array. I want to explain hexadecimal to you really quick. So human beings, computers has 2 bases. Human being has base 10. So the number sequence or the number system we use is base 10, means from 1, actually from 0 to 9. Then this is the sequence, right? These are the elements in our set. In our set, we have 9 elements. Whatever number you pick, whether it's a million or 2 millions, it's always a combination or a permutation of those elements in that set. And how do you go over when you reach the end of the set? So you start 0, 1, 2, 3, 9. When you reach the end of this sequence, then you reset this, the least significant number. You're gonna reset it, means this becomes 0, and then on the left you're gonna add a new slot, let's say, new significance. Then you're gonna go over to 19, right? when you reach the end, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. When you receive the 9, then you increment. Now it is 2, and then 2, 0, 2, 1, 2, 2, 23, 24, 25, 26. When this reaches the maximum, you're gonna increment into 3, and then this resets. Same case. When you reach the end, you're gonna reset least significant numbers, and you're gonna add a new slot. When these 3 slots gonna be full, you're gonna do the same. You're gonna reset zeros, and then you're gonna add 1. So this is base 10. In computers, you have base 2, which is the binary, and then you have also base 16, which is hexa. It's called hexadecimal. Decimal. In base 2, you have the same. So your set is, here your set is 0 to 9. Here your set is 0 or 1. 0 or 1. Now, when you reach the maximum, we reach the end of the series, then you reset, and then you add 1 slot. Then you're gonna increment when you reach the maximum in this, then you're gonna add a new slot. So now I reach the maximum. So now it is 0, 0, 0, 1. Then I'm gonna increment 1, 1. I reach the maximum. So now everything resets and I add 1, and so on, so forth, etc. This is base 2. Base 16, the set is 0 to 9 plus A, B, C, D, E, F. So this is my set. You have 16 elements. So you're gonna start from 0 to F. Once you reach F, this will be reset, and then you add a new slot. So this will become 0, 1. Then the difference here we max out at 99, but here we max out at FF, because you're gonna keep incrementing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, E, F. F is the final. Once you max out, then you reset 0, 0, 1. You're gonna go, for example, at some point you're gonna have A, 5, B. And this is not the maximum. You're gonna go, because you can still continue A5B, A5C, A5D, A5E, ABCDE, A5F. Now I reach the maximum, so I reset and max and increment the next one. So A6, 0. Boom, boom, boom. I keep going until I max out at FFF. If I max out at FFF, then I reset all, and I go from 1, and so on and so forth. So addresses in memory are base 16. Are base 16. Where am I? I am in here, so I'm gonna stop here. So whatever. Base. So notice the address E991FEF678. This is hexadecimal, and look how big it is. It's a huge. See how many memory slots I have? Until this max out, it's gonna be a huge number. Why? Because it is 16 times 16 times 16 times 16 times 16. Each slot can have 16 possibilities, right? If I wanna compute how many slots I have, I need to multiply all slots 16 by each other. So yeah, that's how you get it. I think that's it for today. The next you only need to know about the sorting arrays and multi-dimensional array. We can go over them next session really quick because I think we reached the time. It's 5:30. I think I started at 4:20. Um, okay, have a good day, and I'll post homework 5 or homework 6 and project 3.